So this is Math 1325, chapter 12.5, second video about the absolute maximum and absolute minimum. So we're gonna talk about this second theorem. They say absolute extrema, maximum and minimum, if you have one, must always occur at either your critical values or at endpoint. So remember we were doing critical values when we take the first derivative, right? Because those will lead to like relative maximum and relative minimum when you take your first derivative and set it equal to 0, right? Hopefully you remember that. And then we also need to test at the endpoints. And remember earlier when we look at those graphs, like the absolute maximum and minimum always happen on the endpoints or the regular local relative maximum and minimum, right? Either endpoints or relative maximum minimum, right? All right, so that's why we need to test those. So they list a few steps for you to follow. So when you try to find the absolute extrema in a closed interval, you want to make sure, first of all, this function is continuous between those two values. And then you want to find a critical value that's in that interval. And after that, you want to plug it to the first derivative with the endpoints along with the critical value. And your absolute maximum within the interval is going to be the biggest y value, and the absolute minimum is going to be within the interval the smallest y value. So it sounds difficult, but let's try some together. Hopefully you think that would be not too bad. So we have a function here, and we want to find the absolute extrema of the function. My function is f of x equal to x squared. It's just a regular parabola, right? They give you the closed interval, which is this, which means my endpoint is x equal to -1 and also x equal to 2, right? So those are my endpoints, but I also need to find the relative maximum or minimum using the critical value, right? So find critical values. Hopefully you remember we're going to need to take the first derivative, right? So f prime of x, using that, we should know by now it should be bring down the exponent x and then 1 less than this exponent, right? So f prime of x equal to 2x. To find your critical value, you want to set this equal to 0, right? So when I do that, it's basically 2x equal to 0, divide both sides by 2, x just equal to 0, right? So that's my critical values. And they say you're supposed to test the endpoint along with the critical value, right? So let's do that. So let's test critical values or critical number and the endpoint, which means and then we should plug it into the original function. So be very careful with that, because I want to see the y value on the original function. Is it the biggest? Like, so we're going to plug it back to like our original function with those number. If it's like the biggest y value, smallest y value. But of course, the one we're doing is open a parabola, right? Okay, so testing in. To find the y value with my original functions, I have 3 points to plug in, right? Including x equal to 0, and then my endpoint x equal to -1, x equal to 2, right? So I'm going to need to find f of 0, f of -1 and then f of 2. So plugging back to the original function, equal to 0 squared is just 0. -1, the whole thing squared is +1, and then 2 squared would be 4. So those are my y value for my original function, right? Which one is the smallest? So this one is smallest. So I'm going to say that's my absolute minimum. So absolute minimum at the point 0, 0, x equal to 0, y equal to 0, right? And then which is located at x equal to 0 with the minimum values equal to 0, right? So in case like they ask you a different way on your homework, you know how to answer it. And the second one, the biggest y value is going to be 4, right? So this would be my absolute maximum. So the absolute maximum point is going to be at the point x equal to 2 and then y equal to 4, right? Which means it's located at x equal to 2 with a maximum, or I should say absolute maximum, ABS, absolute maximum values of 4. Are we okay with this? So it's not too difficult, just like what you did before, but this time it's in a closed interval. So that's why we do plug in the critical value along with the endpoint. All right? So the second question is pretty much the same. They give you a function. You need to find the absolute extremer. So, and this is the enclosed interval, meaning those are my endpoints, right? So you got x equal to -3 and then x equal to 2 is your endpoints. And to find that, first we need to find the critical values by finding f prime of x and then set f prime of x equal to 0, right? And once you get that, and then you need to plug in your critical values and also the endpoint to where. So this is the common mistake, right? Where do we plug it in? We need to plug it back into the original function f of x, right? So if you want to, you can pause the video and try this out, and then we can check the answer together. So pause the video and take a minute and see if you can find that answer for us. All right? So if you're ready, so when we try to do f prime of x, so we're using this function. So it's going to be 3x squared plus 3 times 2 is 6x, and the 1 turned into 0, right? So that's my first derivative. I need to set that equal to 0. 3x squared plus 6x equal to 0. To solve that, I need to factor. So I can pull out 3x times x plus 2 equal to 0. So pretty much 3x equal to 0 and x equal to 0 and x plus 2 equal to 0 and x equal to -2. So I got 2 critical value or number, and then I have 2 endpoints. So I'm going to need to plug those numbers to my original function. So just be careful. You're supposed to find the actual y value from the function, so original function. But this time we have 4 numbers. We have 0. I should put them in order, but I didn't. Sorry about that. I have -2. Those are the critical number. And I also have my endpoint, which is -3 and 2. So if that's the case, let's see. plug into the original function here. So we got 0 cubed plus 3 times 0 squared minus 1. That will give me -1. And then -2 the whole thing cubed plus 3 times -2 squared minus 1. You should get a 3. And then we got -3 cubed plus 3 times -3 squared minus a 1. You should get a -1. And the last one, if you plug in 2 cubed plus 3 times 2 squared minus 1, you should get 19. Alright, so the smallest number we got is -1 and also another -1 here. The biggest one is 19, right? So I can say my absolute maximum points is going to be 2 comma 19, which means x equal to 2, and the absolute max value is 19. Sorry, I'm running out of space. And then the absolute minimum points are 0, -1, and also -3, -1. So they are at x equal to -1 and x equal to -3, with the minimum value is -1. So sorry, it's a little bit crammed, but that's what you get. Thank you.